Hi everyone. One of the most fundamental capabilities in all of computer science is the ability to branch based on some condition. In case 1, let's take this action. In case 2, let's take this other action. In case 3, we're going to take a third action. For example, if we want to write a function that takes the minimum of two numbers a and b, well, we're going to need a condition that checks whether a is smaller than b, and if so, return a. Otherwise, return the value of b. In this installment of Programming for Lovers, we will see how Go implements conditional statements, which check whether some value is true, and if so, takes some action. Now, that's a simple idea, but we're going to see throughout the course how it can be applied to more and more complex tasks. As always, if you enjoy what you see, please like, subscribe, and join our course at programmingforlovers.com. Let's code. Let's start by creating a folder within our source code directory called Conditionals. And as you might expect, we're going to create a file called main.go within that Conditionals folder. So we're going to need package main. And I'm going to need a func main also, because I want to run the functions that I'm going to write. But a good initial introduction to if and else is our min2 function. So that min2 function takes two integers as inputs and is going to return the minimum value of the two. So I need my func keyword followed by the name of the function min2. I'm going to use the shorthand where a and b, my two inputs, are both integers, so I'm going to have a comma b int. And then I'm going to return an integer value too, so I need to specify that as the return type. Here, though, we need to branch based off of which of these is smaller, between a and b, which value is smaller. So I'm going to check that, and the way that I'm going to check that is with an if statement. So I'll have if a is less than b, and as with functions, we need to place our if statements within brackets. So I'll put brackets around that if statement in that way. And if it is the case that a is smaller than b, it has a smaller value, then I want to return that value of a. Otherwise, I want to return the value of b. So we need to be careful about how we use the else statement in terms of Go syntax. Go wants us to say, okay, in this other else statement, that else statement needs to occur exactly after that closing bracket of the if block. And we need to have another bracket that starts the else block and that closes it later. So in that case, we know that b is smaller, or they're equal, and we can safely return b. And that's our min2 function. I can now call this function. So just as practice calling a function, let's add a print statement to main that says, okay, well, the minimum of 3 and 4 is, and with a print statement, I can add a comment between things that I want to print, a comma between things that I want to print, and I'm going to call min 3, 4. So when I save that, I'm going to see that I don't have the import of FMT, so I need to import, and I'm going to import FMT. All right, so that's our code. In the terminal, I need to navigate to the conditionals directory. So I'm going to cd into src/conditionals, and I want to compile this code. And I need to call that min2, not min. And that should allow my code to compile, and that will allow us to run the code. And I see that the minimum of 3 and 4 is indeed 3. I can switch the input parameters here, save, compile, and run again. I just hit up to get /conditionals, and I see that the min2 function is working if I switch the parameters as well. So that's all well and good. In our next function, we want to pass from the case of two cases to 3. So we're going to have another function that I'm going to call, let's call it which is greater. And which is greater is going to compare two input integers and returns one of three different values. So we want to return one if the first input is larger, -1 if the second one is larger, and 0 if they are equal. So I'm going to have a function that's called which is greater, and I can call these two integers whatever I like. Let's get out of the habit of naming everything. A and B, let's call them x and y as integers. And here I'm still going to return an integer, but I'm just going to, I need to check. And here I need three cases, depending on is x bigger, is y bigger, or are they equal? So to facilitate these three cases, I'm going to have an if statement followed by an else if statement so that I can have more than two checks. So in the first case, and we can arrange these cases however we like, in the first case, I'm going to check, is it the case that x is equal to y? And when we set a variable equal to a value, we use something like x equal to 4, or x equal to some expression, 4 times y minus 3. We're accustomed when we work with variables to set the values of variables in that way. It's tempting then to say if x is equal to y, and then just return 0. That's not technically correct in terms of Go syntax, because with Go syntax we need equals equals when we're checking whether or not two expressions are in fact equal to each other. So we use single equals to say I have a variable, I want to set its value, and we use double equals to check whether or not two expressions are in fact equal. So in that case they're going to be equal and we return 0. In a second case we're going to have an else if, and in this else if we're going to check, is it the case that x is greater than y? And in that case x is the first input parameter, so we're going to return 1. And then in the final default case, we're going to return -1. Because if we are here, if we make it into this else block, we know that y is bigger than x. And so we can return -1 as intended. We can confirm this function is working as well. So let's go into func main. I'm going to save my code, and let's just print a call to which is greater of 3, 5. So 5 is bigger there, so that should be -1. Let's call which is greater of two things that are equal, 42 and 42. That should be 0. And let's do one more, which is greater of, say, -2 and -7. And that should be 1. Because even though these are negative numbers, -2 is greater than -7. -7 is more negative. So when I save that, I should be able to come down. I can hit up twice to get me to go build, since that was 2 previous, so that compiles the code. Up twice again, because 2 previous commands was running conditionals. And I should see -1, 0, 1 printed. That was what we were hoping for, which is indeed what gets printed. One more aside before I would continue on, which is that sometimes you don't technically need kind of your default else behavior. So I like functions like this, for example. To me that's very clear. But technically, sometimes when you have an if statement, you're not returning a value, you're just taking some action. And you only want to take that action in the case that you're considering. In this case, we have a return statement. So if A is indeed less than B in min2, we're going to return A, and we're never going to consider anything else in the function. The function is going to be finished. So in that particular case, we don't need this else statement. Because if we make it into this part of the code, if I save the code, it's going to format it nicely. If I make it into this part of the code, I can conclude, I don't know why the word conclude was difficult for me today, but I can conclude that B must be smaller because otherwise if a were smaller, I would have already returned and the function would be finished. So in this particular case, it's going to be okay to just have the default behavior of returning b. That's just a note. If you like else blocks, even in these cases where you don't technically need them, I am fine with that. I think that's good coding practice, especially as you get started. Let's do one more function. So let's do another example. Let's write a function called same sign. Okay, and this function is going to return not an integer. It's going to take two integers, but it's going to return a Boolean value. So it's going to take as input two integers. What is it going to return though? It returns true if the two integers have the same sign, and false if they have different signs. All right, so I'm going to have, we can call them x and y again, two integers. This time I'm not returning an integer, I'm returning a Boolean value, and so that's specified with the bool keyword in Go. And you might think for a moment about how we're going to solve this. If you want to pause, you're welcome to it. I might think about it as needing three different cases. Maybe if x and y are both greater than 0, in that case return true. Maybe if they're both less than or equal to 0, we're going to return true. And then maybe a remaining default case where they have, we know if we make it there that they have different signs, and we can return false. I think that's a perfectly fine way of going about solving this problem, but I wanted to point out, one of the elegances of programming is sometimes even what might seem like a relatively straightforward, boring problem like this can have a nice, elegant solution. It's a shorter solution that relies, for example, on some mathematical fact. So in this problem, regardless of how I'm implementing it, I'm assuming that 0 can be considered both positive and negative. So in other words, 0 has the same sign as every integer. Is it positive? Is it negative? It's kind of neither. I'm going to say it's kind of both. And the shortcut that I'm going to use is to say, well, x and y have the same sign when the product x times y is, well, if they're both positive, it's going to be positive. I should say positive or 0. It's going to be greater than or equal to 0. If they're both negative, that will flip the sign. So if they're both less than or equal to 0, then x times y is going to be greater than or equal to 0. So in either of those cases, when you multiply the two numbers together, you're going to get a resulting product that's greater than or equal to 0. And so I'm going to use that to help me write a nice short function here, which is, let's check, is it the case that x times y is in fact greater than 0? In this particular case, then I know they must have the same sign, and I'm going to return true. You can have the rest of this function however you like. We have a return statement, so you don't need the else statement if you want to say in all other cases we're going to return false. When this product x times y is less than 0, well, that means you have a negative product. The only way you can have a negative product is if one of x is positive, the other one is negative. I don't actually care which one is positive, which one's negative. I can get it quickly from the product. So in this other case, I say I know that x times y is in fact negative. So you can write the function this way, or you can get rid of your else. Make sure to get rid of your closing bracket, save, and you have your slightly shorter function there. There is an even faster way of writing this, which is that technically this expression here, x times y greater than or equal to 0, is going to be a Boolean, have a Boolean value. That expression gets evaluated behind the scenes in the programming language. And when we run that, it's either true or false. So if it were true, that's what I want to return. I want to return true. If it were false, I want to return whatever this has. So I could get rid of all this code and have a one-line function which is simply to return x times y greater than or equal to 0. I will note, if you have familiarity with programming, these are the types of things that you might use later on as you get very, very comfortable with programming. If you're relatively new to programming, or you simply don't like this, which I'm kind of in that boat. I like things that look clear and have a nice intuitive feel to them. This is very codery. It's very very short and succinct, which is nice, but you might not see this initially, and if you don't, that's okay. And if you're not comfortable working with that, then I'm fine with that. I actually am going to keep the function the way that it is. But I want to point out there's an even faster way of writing this function, which is simply to return this expression. Okay. One more function that I want to consider, and as I mentioned in a previous video, the order of these functions doesn't matter, so I'm just putting them in no particular order into my main.go file. But the final function that I want to work with is going to be called a positive difference. And positive difference is also going to take as input two integers, but it's going to return the absolute value of the difference between these integers. Okay, so if we plug in 3 and 5, regardless of how we plug them in, I want to return 2 because the difference between 5 and 3 is 2. So I take the positive difference, in other words, between those integers. So let's write the function signature, the first line of that function. We're going to call it positive difference. Let's go back to calling these a and b. I'm certainly going to return an integer. And I could even return an unsigned integer, but I like working with all integers, so I'm going to continue this as an integer. And in this case, I'm going to have 3 cases. So the 3 cases that I'm going to consider is, and I technically could you do this with 2. I'll let you think about how I could do it with 2, but I like considering just 3 nice clear cases for this particular example. One is if they're equal. And if they're equal, I know that the positive difference between them is going to be 0, which is what I want to return. Otherwise, if a is greater than b, well, if I know a is greater than b, then the positive difference is going to be a minus b, and that's what I want to return. And in the final default case, I can infer that b is greater than a. So if I've made it here, a is not equal to b, a is not greater than b, a must be smaller than b. And I'm going to return the difference b minus a. So that's our function. And the function as written is complete. But I want to use this function to talk a little bit about the scope of variables. What do I mean by the scope of variables? So I want you to consider, say for a moment, that we instead have this intermediate variable that we want to use to represent the difference between a and b. So, for example, say that I were to here declare a variable c to be an integer and set that integer equal to a minus b. And I'm going to use c within the else block also. So down here I might set c is equal to b minus a, and if we make it down here, then I know a is not equal to b because otherwise the function was returned. So c must have been set somewhere within one of those other blocks. And so as a result, I can return whatever value that c is storing. So it's storing the difference between a and b as a positive difference, and I can return it. I can save that and then come into my terminal and compile the code. And what I will see is what I have expected to see, which is a compiler error. It tells us on line 31 that c is declared and not used, which is weird because c is equal to a minus b. So the question is what's going on here. And even if you set this equal to a minus b and compile, we still get compiler issues. So you say, how is it that c is undefined on line 34? It's undefined here. undefined here. You say, I am using it. I declared it. I set it equal here. I also returned it later, but then it's saying it's undefined. So this again might seem like some kind of buggy behavior or very strange. In fact, it's very good behavior that is going to make us strong programmers. So when you define a variable or declare a variable, it has a lifetime. And the fancy term that we use for the lifetime of that variable is scope. So the scope of a variable in general terms is the block within which it exists. So when I declare this variable here, C, the scope of this variable is whatever block it's in. So within this block, C gets declared, and then as soon as this block is over with, C is actually destroyed. We lose C from the memory, which is a good thing to do to have your programming language clean up things, since if you have a lot of variables and a huge program, you want it to go ahead and handle these things for you and get rid of things that you're no longer using. That is a great feature. In this particular case, the fact that it has scope only within this block has meant that when you come into the else block and set it equal to b minus a, it doesn't know what C is. Similarly, when you're here, this is outside of this block, and so it simply does not know that C exists. C has been declared, but it's already been destroyed in this case. And that's also to produce some sort of safety, because it might not have been the case that you even made it into this block. And in that case, how would you be returning C? So you can't return something that you didn't ever declare. So from the perspective of the programming language, this ensures that everything is going to work when you run it, and you're not going to get some extremely weird bug that you don't understand. So scope is a good thing. And one of the ways that you might work around this is, well, okay, maybe we could redeclare C to be equal to b minus a if it says it hasn't been defined. Well, let's define it again. But the problem with this, when I save and compile, is I'm still not using it. It's still not defined at this point, because we have we have two different C's. One that has scope in this block, another that has scope within this block, and this is outside of both of those blocks. It's sort of one level higher up in terms of the function, because the block that this lives in is the entire function. So that didn't really fix anything. And the way that if we were going to fix it in this way would be to declare it so that this C is able to actually see the variable that we're interested in, pardon the pun. And so I could declare C outside as this integer, so that the scope now is whatever block it's living in, which is the entire function. And so instead of declaring C again, I could set C to be equal to a minus b. And here we could set C to be b minus a, and now I'll be able to return C, so that when I compile this, at this point, I'm going to get a working function. Go is okay with this. So one more thing I would note about scope in this particular case is you might be wondering about A and B. And we've already seen this in a previous lesson where we talked about passing in parameters by value. So when you have a variable outside of a function, then you pass that variable into a function, a copy of that variable gets created, and it's that copy that gets edited within the function. Another way of thinking about that is that the scope of that variable, the lifetime of the parameter, is just the function. So if we're outside of a function and we call that function with two other integers, copies of those integers get created, and their scope, their lifetime, is only within that function. So now hopefully that makes sense a little bit more than when we saw it previously. One more thing that I want to cover before we end the lesson is to point out a little bit about comparison operators. So we've seen how to compare values of variables in a few different ways. We've seen a greater than symbol. We've seen an equal to comparison, which is a double equals. And we've also seen something like greater than equal to. So if we were trying to insert the single, like we tried to use the symbol greater than or equal to, it wouldn't be interpreted by Go. We need greater than followed by equal to. All right. And you'll note, actually, when I hover there, it's giving me the suggestion to simply return x times y greater than or equal to 0. So that was the extension here giving us a suggestion on how to make our function shorter, which is nice. But for now, I want to point out, okay, we've got a greater than or equal, we've got a greater than symbol, we've got a double equal. What are all the possible comparison operators that we could use? And so I'm going to put these all into a lengthy comment and just point out what they are. So what you might expect, greater than is just the greater than symbol. The same thing for less than. Greater than or equal to is the greater than symbol followed by equal. We have a less than or equal to also. We have equality, which I said was double equals. We also have not equal to. You don't want to use the not equal to symbol. You want to use exclamation mark equal, also sometimes called bang equal. And then we also have something that we might use sometimes called, which is just an exclamation mark. And this means not. So for example, if x is Boolean, then not takes the opposite. So not x is false when x is true, and true when x is false. We might see that later in the lesson, or later in the course, but for now I think we have a good handle on what the purpose of the lesson was, which is to introduce us to starting to work with if statements, else ifs, and else. So I hope you had a good time. I'll see you next time, and in the meantime, happy coding.